Okay, just to finish up this problem, are they parallel, orthogonal, or neither? Let's try parallel. Is one vector a multiple of the other? Well, uh, if I took -5 and multiplied it by -3, I would get 15, right? So if I took -5 and I multiplied it by -3, I would get 15. If I take 12 and multiply it by -3, do I get 45? No, I don't. So there's not a multiple, like this vector is not a multiple of that vector. Another way you could think about it is, like if you don't want to have to sit there and think about what would multiply, you could take the 15 and the -5 and divide them, and then ask yourself, is that the same thing as 45 divided by 12? Would they have that same ratio? And these don't, so they're not parallel. Okay, so they're not parallel. Let's try orthogonal. Again, orthogonal, you need to do the dot product. And we want to see if it's equal to 0. So let's do 15 times -5 plus 45 times 12 and see if that equals 0. Well, this equals 465. That's not 0. So they are not perpendicular. Or orthogonal. So that means it's neither. Okay, let's see what's next. Let's just do B. We have one vector here, we have another vector here, but we don't know what this value of B is. We want to find B so that they are orthogonal. Orthogonal is the dot product of 0. So if we did 5 times 4 plus -2 times B, that should equal 0. The dot product should equal 0. So let's solve this. 20 minus 2b equals 0. We could subtract the 20 and then divide by the -2. So b would equal 10. Okay. I think we'll stop there. Yep. We'll stop there. So just going back here, they're parallel if one vector is a multiple of the other. Like you could think of something to multiply by to get the other vector. And orthogonal means the dot product is 0. Going back here, this is the formula for the angle between two vectors. Just remember at the very, very end, to get the angle alone, you have to do the inverse cosine of all of that stuff. And then this is just the general formula for dot product. So now you should be able to go and start the homework, and I will see you on Friday.